Welcome back to machine learning. This video will cover bias and fairness. Let's first talk about the current state of ethics in AI and machine learning. Currently, we have a system set up on 4 pillars: fairness, robustness, transparency, and explainability. There's no universal measurement for fairness. We have lots of different things that we evaluate to give us a sense of fairness, but there is no universal understanding of what fairness is. Robustness refers to the idea that a system should be reasonably able to handle different errors or different adversarial attacks. Transparency refers to the idea that we should be able to peek into a method or a model and identify how it's working. And explainability refers to the idea that a model should be able to provide justifications for its choices. There are many different toolkits for all 4 of these pillars. For fairness, there's Google's What If tool. It's so named because it's trying to address the question of what if you could inspect a machine learning model with minimal coding required. The idea is that it's supposed to be used for people outside of computer science, outside of machine learning, to take a model that exists and run different fairness tests on it. Some of the things that we have here show custom thresholds, group unaware, demographic parity, equal opportunity, equal accuracy, and group thresholds. So basically, you're able to change the different demographics, you're able to evaluate equal opportunity of different groups, and give you some sense of fairness. IBM's AI Fairness 360 is another toolkit that exists. IBM is sort of the leader in this space. They have toolkits for all 4 of the pillars. This is a little screenshot of their toolkit, and my favorite part about this is that Google asked me if I wanted to translate this page, which means that Google doesn't even think it's English, which is hilarious because the idea is that we're supposed to be building these type of toolkits for people that are non-technical so that they can understand how fair a model is. This is basically just a system for computer scientists to evaluate their own methods. A lot of the different indices and measurements that we use are basically just mathematical measures of quote-unquote fairness, again, because there is no universal definition of fairness. IBM also has an adversarial robustness toolkit. An adversary is basically an enemy or someone that's really trying to work against you. And a really common thread in a lot of machine learning right now is adversarial training. The idea being that you're training 2 things at once. You're training the model that's trying to solve your task, and then you're training a model that's trying to interrupt that process, an adversarial model. And the idea is in this sort of two-pronged approach, you're able to train a model for prediction that can handle this sort of adversarial attacks. So it can handle things that are sort of unexpected and interruptions in the normal training and testing flow. So IBM introduced this adversarial robustness toolkit that uses adversarial testing. So it basically throws a bunch of different tests at it to basically mix it up and cause problems for the model, and it's able to give a sense of robustness based on these tests. IBM also has fact sheets for AI services. This is their attempt at addressing transparency. The idea is that these AI and machine learning systems are built by people, and so people understand what went into them. So someone will create a system, a model, whatever, and they will say, okay, it was trained on this type of data, it's never seen this, this is how it's supposed to be used, this is not how it's supposed to be used, so on and so forth. The problem with this is that most people are not doing this, and certainly most companies are not going to reveal what data they used to train on, and so this isn't necessarily a widely accepted way of handling transparency. There's also the AI Explainability 360 toolkit. The idea with this toolkit is that you can take different models and identify what your interests are, what you're interested in understanding about the model. So specifically, they have you choose a customer type. So you can go through and you can say, I'm a data scientist, this is what I want to know. Or I'm a loan officer, this is what I want to know. Or I'm a bank customer, and this is the information that I'm interested in. And so based on who you are and what you're interested in, the model can provide explanations, custom, sort of tailored to those people. The only problem with this is that it kind of expects that the model has some sense of explainability built into it, and many people are not working on explainable systems. Although this is a good start in addressing ethics in AI and machine learning, these 4 pillars don't really get to the heart of what it means for a system to be ethical. When we talk about ethical AI, there's a lot of problems with it. And in particular, we're STEM professionals, science, technology, engineering, and math professionals, and we're trying to define ethics in this space when really it's a philosophical question, and we should be addressing it in an interdisciplinary and multidisciplinary fashion. And many times, ethical considerations are added as an afterthought. So once the system is built and it's working well, we then kind of perform these evaluations and say how ethical it is or how fair it is or so on and so forth, when it really should be part of system integration and development. When we're talking about ethical AI, we need to think about what it means for an artificial intelligence agent or a machine learning model or algorithm to be ethical. And AI that is ethical can kind of fall into one of 2 categories. We can think about it in terms of the AI behaving morally or the AI serving the interests of the people. Let's start with the first one. If we think about ethical AI in terms of a moral AI, an AI that behaves morally, then we kind of need to get into the word moral and kind of identify what it means. Moral is to be concerned with the principles of right and wrong behavior. I have a problem with this, and I think all of you should as well, because what we're doing here is we're attributing human characteristics or behavior to a program. So we're basically saying that this AI or this machine learning model or algorithm is human-like, and it is not. So this is known as anthropomorphism, and I also like to call it dangerous, because a lot of what's happening right now in AI is that people outside of computer science don't understand it, and they think it's dangerous because they think it's human-like, but it's really just calculus. And so we need to understand and better communicate what that means. And so in this space, when we're talking about moral AI, it just doesn't seem like a good fit. But I'm going to drive this point home. A moral agent is a person who has the ability to discern right from wrong and to be held accountable for his or her own actions. Moral agents have a moral responsibility not to cause unjustified harm. Now, this one is really important. Traditionally, a moral agent is assigned, moral agency is assigned only to those who can be held responsible for their actions. So children are actually not considered moral agents up to a certain age because they are not responsible for their actions, right? No one would say that a baby was being harmful on purpose because they slapped somebody. So if a baby can't be considered a moral agent, then an AI certainly can't be. So with all 3 of these sort of definitions of what it means to be moral, we know that doesn't align with what an AI or a machine learning algorithm is. So we need to talk more about, okay, well, who's responsible for the morality of an artificial intelligence system or an AI or a machine learning model or algorithm? Well, it's the creator and the user, right? So as the creator, you need to be aware of how your system is going to be used and in what conditions, and you need to make it as fair as possible, and you need to try to address as many concerns as possible, and you also need to make sure that people know what the limitations of the method are. A big problem in computer science in general in research is that people write these papers, these academic papers, and they say, this is the best method since sliced bread, everything's great, definitely no downfalls. And then people use it and it doesn't work in certain situations, and they have no idea why, because they claimed in the paper that it works great. And so we have a problem of not addressing our limitations. And I think that's a real problem in the field. And so as the creator, you need to be able to, cop to the limitations of your method. It's okay. You're not going to solve everything with one model or one algorithm, right? Or one data set. you need to be able to say, like, the limitations of this method are as follows, and it should be not be used in these conditions. And the user is also responsible for the morality of the system, right? No matter what the creator does and all the safeguards they put in place, right? If the user wants to use it for malicious purposes, they will do that. So it's up to both the creator and the user, right? So the responsibility ends up on the human in this equation. If we go to the other definition, where AI is ethical if it serves the interests of the people, then we talk about a serving AI. An AI that serves the interests of the people doesn't actually attribute human characteristics to something that's not human. So that's good. That's a good start. And basically what we're saying by AI that serves the interests of the people is we're saying that the AI should be used for the common good. And I think that's something we can all agree on. And if it's being used for the common good, one question that still remains is which people are being served? And that's when we really need to consider diversity, equity, and inclusion in our work. We need to think about, how is our method affecting a diverse set of people? How is our method allowing everyone a seat at the table? And how is our method making sure to include everyone's voices? Again, we come to the question of who is responsible for ensuring that an AI system is serving the people. And it comes again to the creator and the user. The creator has to think about who the system that they're building is serving, right? And the user has to think about, am I serving the people that I'm using this method on, right? So am I serving the population that this method will be used for? Let's talk about some ethical failures of AI before we go more in depth into bias and fairness. So a couple years ago, IBM came out with Watson for Oncology, and the idea was that they wanted to be able to identify patterns in significant amount of patient data to hopefully lead to some kind of cure for cancer, right? So what they did is they took a bunch of patient data and then they actually created synthetic data based on that patient data. And the problem with that is that synthetic data is created by a machine, and so it doesn't follow the normal patterns. So the idea of creating synthetic patient data likely came from the inability to get patient releases on their actual data. So they created the synthetic data, and then when they actually created this machine learning AI system, it made unsafe and incorrect treatment recommendations. It was basically telling some patients to take so much Tylenol that they would die, they would overdose. So this is a real problem because they thought they were solving a real issue and they had such a good potential, right? But they weren't thinking about the consequences of using synthetic data when it really came down to it. And also just a couple of years ago, Microsoft released a Twitter chatbot named Tay for conversational understanding. They basically wanted her to crawl the depths of Twitter and learn how to converse with people on Twitter. And of course, they didn't take into account that people on Twitter are trolls. And so as soon as they released her, everyone was trying to get her to say bad things. And she went from 0 to racist in 24 hours. And she was spouting off horrible, horrible things, and they had to take her down within 24 hours of unveiling her. And it was ultimately it was their fault because they didn't think about how the users were going to interact with her. And they didn't think about putting in safeguards to protect people from the things that it ended up learning to say. So what can we do to create more ethical AI? Well, the first thing is that we can really try to manage bias wherever it exists. And there are two main sources of bias in machine learning, the data and the algorithm and model. We're going to go through both of these in turn. For data bias, we have a couple of different options, and there are many more than this. But basically, biased data can cause bias in the model and algorithm. When we're dealing with big data, there's typically bias in the data because of the way it's collected and what it represents. There are many different types of biases that can be present in the data or the way the data is represented. We'll go over a couple here. Let's start with historical bias. Historical bias already existing is an already existing bias, and socio-technical issues in the world can seep into oh sorry basically it's something that already exists in history, and it can kind of seep into the data generation process, even giving us perfect sampling and feature selection. So here's an example specifically, right? So when I Google man CEO, I get images of actual CEOs from different companies. And when I Google woman CEO, I get a couple images of women that are CEOs. And I also just get a bunch of like stock photos of women leading meetings or like looking out windows in New York City, I imagine. And so first off, it's giving us kind of a sense that like there's more male CEOs historically than there are female CEOs. And so we're not really seeing real images in the female CEOs. So that gives us some issues. And then when you actually check to see like the hit ratio on these search terms on Google, you see that it's a 200 to 84 ratio. So there's way more hits for male or man CEO than there is for woman CEO. Now, representation bias happens from the way we define and sample from a population. So here I have an example where I search for long hair. So if I just do a Google search for long hair with no gender information, female images are returned. And not only that, we get women that are around, I don't know, in their 20s, I guess except for J-Lo, like in their 20s with really long hair. And so I'm not seeing anybody that's male. I'm not seeing anybody that's non-binary. I'm not seeing anybody that's older. I'm not seeing anybody that's like a kid. So that's already causing issues, right? And then when I actually click on the little men tag, all I'm seeing is white men with the like exact same hairstyle. So this is an issue as well, right? Because now I'm not seeing people of different races. And all I did was look for men, long hair. So representation bias is a huge issue. Now, measurement bias happens from the way we choose, utilize, and measure a particular feature. So a good example is a reform system, right? So when people go to prison or go to jail, we want, once they've been reformed, we don't want them to go back, right? So it turns out that minorities end up going back at a much higher rate than non-minorities. And part of the reason for that is because people in minority communities are more strictly policed than non-minority communities. So the idea is there's actually more measurement in minority communities because there is more policing in those communities. And so it's not that they're necessarily going back into the system more frequently. It's just that they're getting caught more frequently because of the way that the measurement is being done. Evaluation bias happens during model evaluation. So if you think about a system that you're training for face recognition, if you train it and then you evaluate it on data like this, you'll probably get a model that is really good at recognizing white people. So if you are not necessarily intending to train a model that's only good at recognizing white people, then you need to make sure that your test set also includes people from all different races, different ages, different genders, things like that, and so that it's representative of the real world. Because if you're training on real world data but evaluating on something that's not realistic, then you have introduced evaluation bias into your model. So there's a ton of different data biases, and these are just a couple of the most common ones, with historical and representation bias being sort of the most common biases that we deal with in machine learning. Now, algorithmic fairness, specifically, when we're trying to talk about fairness, I said earlier that there's no universally accepted definition of fairness. It's been long studied in philosophy and psychology. Fairness can be thought of as the absence of any prejudice or favoritism towards an individual or a group based on their intrinsic or acquired traits in the context of decision making. What kinds of discrimination can an algorithm exhibit? Well, it turns out a lot. We'll go over a couple here. Let's start with direct discrimination. This happens when protected attributes of individuals explicitly result in non-favorable outcomes toward them. So just 2 years ago, Amazon retired this system that they were using for resume reviewing. They had an automated system that looked at resumes for potential employees and gave them scores. And those scores would be used to determine if they would get reviewed or if they would get interviewed and things like that. It turns out that the system was trained on data that had been from Amazon from like 10 years prior, and there were mostly men at Amazon. And so what it learned to do was recognize that female candidates were less worthy, and so it put them at the bottom of the pile. And so what's happening here is that one of your protected attributes is basically being used against you in a hiring decision. So if we talk about indirect discrimination, individuals appear to be treated based on seemingly neutral and non-protected attributes. However, protected groups or individuals will still get treated unjustly as a result of implicit effects from their protected attributes. So an example of this is zip codes for loans. Zip codes don't really say much in themselves, but they can actually tell you, even though they're not a protected attribute, right? They're not associated with your identity. They can be used to tell whether or not you live in a quote unquote poor area or a wealthy area, right? And so with that information, loan officers can decline a loan, which is basically using information that has nothing to do with you and your protected attributes, but it's still making a judgment and indirect discrimination against you. Systemic discrimination refers to policies, customs, or behaviors that are a part of the culture or structure of an organization that may perpetuate discrimination against certain subgroups of the population. Everyone exhibits this type of bias in terms of having a bias for in-group versus out-of-group. So we're all familiar with the idea of systemic bias in the sense that we tend to gravitate towards people that are similar to us. And that doesn't necessarily mean that we gravitate away from people that are different from us, but we end up giving an advantage to people that are like us. And this becomes systemic bias when it is incorporated into hiring practices and other aspects of a company or organization. And when you think about it in terms of government and society, it's a very similar sort of structure. Statistical discrimination is a phenomenon where decision makers use average group statistics to judge an individual belonging to that group. A good example of this is going to be the gender pay gap that exists in most countries. When hiring a new employee that may be a female, they will use average statistics of prior female employees and make assumptions about whether or not they're going to have kids and so on and so forth based on statistical data. And that ends up perpetuating this sort of gender pay gap, which in the United States is 18.2%. There are many, many different types of discrimination that algorithms and models can perpetuate. And so we only cover a few here. But it's basically a never-ending list. So how do we deal with bias? Understanding that it's basically everywhere and it comes from all aspects of the machine learning pipeline and process. How do we deal with bias in innovation, right? And I personally believe it has to do with teaching innovators of tomorrow to be aware of these things. One real issue that we deal with today is automation bias, which makes humans favor suggestions from automated decision-making systems, right? So we tend to believe the automated system, even when we have contradictory information that's correct from a non-automated source. So it basically blinds us a little bit, and this is becoming a real problem. And so we have to think about bias in all aspects of the machine learning development and pipeline. Teaching the next generation of innovators to keep this in mind, I like to frame it in terms of education. So there's a concept in education that is universal design and learning, which is supposed to give equal opportunity and access to people with different abilities. And the idea is basically summarized in this like panel of pictures, where if you're watching a baseball game and you give everyone equality, right, then you would give everyone the same thing, which is this like little box to stand on. But some people have more advantages than others, and so this tall person gets to see the game, this somewhat tall person gets to see the game, and then the short person doesn't get to see the game. And so instead of equality, we move to equity, which is this center panel, which basically says, okay, not everybody needs the same things to be at the same place. So if we adjust everyone's starting place, then we have equity. And that's fine, everybody can see over it. But the idea of universal design and learning is to just remove the barriers altogether so that we don't have to adjust the people. Instead, we're just adjusting the barriers. So if we replace the wooden fence with a chain link fence, nobody needs actual adjustments and everybody can enjoy the game in the same way. So this is an educational framework that's focused on accessibility and improved learning for all. And if we think about it in terms of innovation, then if we design with accessibility in mind and equity and inclusion and diversity in mind, will lead to more disruptive and useful technology, and technology that's more ethical, and technology that's less biased and more fair. If we think about this particular example, this is just a means of going up 1 or 2 levels outside, and there's stairs, so people can use the stairs. There's also ramps, and it's not just for people in wheelchairs, right? Think about people that are carrying groceries in a cart. Think about someone that's pushing a baby in a stroller. Having ramps is really nice for everyone, right? And having the ability to decide how you're going to go up is nice, especially if you think about somebody that like broke their foot or something. And so right now they need a ramp, but typically they prefer stairs. And then there's also these blocks here that allow children to play while they're going up the stairs, or just another means of going up these 2 levels. So if we think about designing things in a way that just makes them accessible, then we don't have to have it as an afterthought, and it can be more interesting and more usable by everybody. If we think about universal design and innovation, we can think about 2 examples that I like to bring up that I think would have happened a lot sooner. So virtual assistants are pretty common these days. Everybody has Siri or some version of that on their phone. And then people have Alexa and Google Home in their homes to be able to, turn on the lights, play music, set a timer, do whatever. If we had been focused on accessibility from the beginning, many, many years ago, thinking about what people with visual impairments need, thinking about what people with other disabilities need, I think virtual assistants would have come along a lot sooner, and they would be even further along than they are right now. And ride-sharing services is another great example of this. Uber and Lyft have gained a lot of popularity in recent years, and if we had been thinking about how to help blind people get around or people with cognitive disabilities, then we would have actually probably had Uber and Lyft a lot earlier and really disrupted the taxi service. So basically what I'm trying to get you to think about as a part of this topic is ethics and bias and fairness in machine learning and AI are something that should be thought of at every step of the process. It shouldn't be an afterthought. Make sure your team is as diverse as it can be, and get feedback from a diverse set of people, and make sure everybody has a seat at the table and everybody can voice opinions and concerns and really take them to heart and try to address those things before it becomes a disaster for you. And I think a lot of companies focus on mitigating these sort of disasters, but if you think about it in terms of accessibility and bias and fairness and ethics at the beginning, and you have all these people at the table, then these things won't happen, and you'll actually make more interesting and disruptive technology.